Non-metal, guys, non-metal. All right. I got one more thing that I want to teach, which is on this page. Now I'm going to have to move on, but I do want you to know during the final, all these notes that I'm offering will be available to you. So make sure that you have clear notes, that you're referencing your information, because you're going to find all the answers right here in the stuff that I'm giving you. Okay. This last piece I consider the most fun. Hopefully you will as well. And you're going to have several questions based on this information. Okay, so let's take a look here. If I had more time, I would have you guys pull out your element research, because this information you guys found when you did your basic info. This one is mine, gold, right? And over here in this basic info section, you will find some numbers for electronegativity 1.93. Here, ionization energy is here, 1,402. Okay, and then atomic radii is the same as radius, 174 ppm. Now these numbers don't mean anything to you right now, but if I had my full lesson, what I would do is have you guys compare your numbers to other people's numbers and see, and see if we can find a trend. Because we don't have time for that, I'm just going to give you guys the answers and let you practice, okay? But that's why I had you do this, so that we could do this kind of more full compare and contrast thing. I'd have you guys in groups talking to each other. It's normally a lot of fun. But for those of you that are taking notes, if you have blank paper, draw a little fake periodic table like this in this basic shape, because I'm going to put the information inside the shape. Okay, so for example, atomic radii tells us how big. Okay, atomic radii answers the question, how big? And this is the deal. I want you to put a large circle here. I want you to put a tiny circle here. And then I want you to put two medium circles here and here. For ionization energy, I want you to put the large circle here. Please put the tiny circle here, and put your two medium circles here and here. And for the last one, electronegativity. Large circle goes here. Tiny circle goes here. Medium circle here, here. Okay. I'm going to ask specific people to give me answers to these questions. This is all the notes. Now we're just going to start playing around with the information. Okay, first up is Marcel. Marcel, if you're ready, hit ready in the chat, please. All right, Marcel, here's your question, sir. What is the tendency of a, oh, let me give these notes and then I'll ask the question. Sorry, Marcel, just give me 1 second. Ionization energy is the energy to remove an electron. And then electronegativity is attraction for electrons. Okay. Sorry about that. Marcel, here's the question. What is the periodic trend? Does atomic radius get bigger as you go up or smaller as you go up? The question is bigger or smaller. Which one is the correct answer? As you go up the periodic table, do the circles get bigger or smaller, sir? Smaller is correct, smaller. Okay, next question goes to Edith. Edith, if you're ready, put ready in the chat, please. It's 2:15. We got 10 minutes to get out of here. Edith is ready. Same question, ma'am. Bigger or smaller as you go to the right? Bigger or smaller as you go to the right? Smaller is correct. And one. All right, very good. All right, let's see if we can pick this up. I'm gonna go with Jada Rich. Jada, here we go. As you go, how are we doing this? Up. Bigger or smaller, Jada, as you go up? Bigger. I'm gonna stick with Jada. As you go to the right, bigger or smaller? Bigger, bigger. All right, fantastic. Last one for Angie. Angie, can I count on you, Miss Angie? Let's do this right quick. Angie, you with me, ma'am? As you go up and as you go right, give me two answers, please. Bigger or smaller? Angie, take a look at these circles, girl. From here to here, definitely bigger. But going up, is that smaller? Smaller going up? Nah, boo. That's bigger going up. Ah, there we go. Bigger. Okay. Thank you very much, everybody, for participating. Now, here's how this is going to go on the test. (217). Thompson is going to give you two elements, and you have to tell me which one is whatever, bigger or smaller. Okay, so I'll give you an example. All right, it's free for all. Anybody can answer when you know the answer. Okay, I'm going to start with atomic radii, how big the atom is. I'm going to give you two elements. I want you to tell me which one is smaller. Smaller. Magnesium or chlorine? Which one is smaller? Anybody can answer. First in gets and 1 point. CL, very good. Marcel owns it. Same question put in reverse. Which one is bigger? Bigger. CR or CU? Which one is bigger? Ooh, we got some controversy here. Which one is bigger? Correct answer, CR. Oh, Angie, Marcel. Oh, remember, smaller as you go to the right. CU is on the right. So this would be smaller. Therefore, CR would be bigger. Ah, now do you see what I see? I'm going to flip it in the interest of time because I want to get you out of here. Ionization energy. How much energy to remove an electron? Okay, notice the pattern. I'm going to ask you the question. Which one has a bigger ionization energy? Fluorine or iodine? F or I? Which one has a bigger ionization energy? Bigger, baby, bigger. Angie, listen, whatever you think it is, Angie, do the other one. F is bigger because it's higher up. So bigger would be higher up. Okay, all right, let's try another one using this example. This time I'm gonna go smaller, so you have to think backwards, right? Okay, which one has a smaller ionization energy? A smaller ionization energy. Let's say molybdenum or tungsten. Which one has a smaller ionization energy? MO or W? Smaller, smaller, smaller. It's bigger as you go up. That's all right. We're going to practice. Bigger as you go up. So if I say which one is the smaller, well, CR would be the biggest because it's highest. Smaller would be W. W is smaller. Okay, now we're working it. Okay, so W would be smaller. I'm going for my last group, last examples, and then we're going to get out of here. Notice the pattern. I'm always going to give you two to compare. They're always going to be on the same line, right? I'm not going to be like B and then BR, okay? That's not fair. So it's always going to be in line, either up and down or left and right, and you will compare them and tell me. All right, so here we go. Last examples. Which one has the bigger electronegativity? Bigger electronegativity. Mg or SR? Mg or SR? Which one is bigger? Mg or SR? Jada not even playing with me. Jada like, I dare you. Great job, Jada. Yes, magnesium would be bigger, okay, because it's higher up on the row. So this would have a bigger electronegativity. All right, let's go on to the opposite, smaller electronegativity. Which one would be smaller? Smaller. I got to do it this way. Smaller. RH or PD? RH or PD? Which one would be smaller? Smaller. Between RH or PD? Which one is smaller? Answers are coming in. I got a little RH and a little PD. Looks like RH is taken away, running away with it. RH or PD, which one is smaller? Well, this arrow says it's bigger as you go to the right. So everybody except Marcel is correct. The one on the right would be bigger, PD. So if I say which one is smaller, it would be RH. RH is the correct answer, okay? Now, I'm gonna give you guys some more practice. Let me come on up here. All right, guys, that's the end of our day. So you guys have a bunch of notes, and I'm gonna be posting a bunch of videos tomorrow. I'll also be trying to get out the practice problems so that you can practice these and test yourself. Remember, you should be able to take them as many times as you need to until you get a perfect score. Make sure that you go for the perfect score on these Google Forms, because the Google Forms are the source for my final exam. So the better you are on the Google Forms during the review, the better you'll do on the test. All right, guys.